So we're going to get started. You will absolutely need a calculator today, and ideally not one that's your phone. It can be done, but it's annoying. And we're going to get into not necessarily complex calculations, but long calculations. Okay, so you want a calculator that you can use well. If you only have your phone, it will work. Just if you have an actual calculator somewhere, a scientific calculator, grab that. So I asked you guys to start with this warm-up, which you were going to solve by factoring. So when we go through here, and I crossed one out because we didn't learn about complex factoring. Remember here, I'm looking at what's a number that will multiply to the C value, so -6, and add up to the B value, which is +1. So for -6, I could have 1 and -6, or -1 and 6. 2 and -3, -3 and 2. No, that's the same factor pair. -2 and 3. So I pick the factor pair that will add up to 1, which is this one right here. And that leaves me with x minus 2 times x plus 3 equals 0. Now it says solve. It doesn't just say factor. So then I would say, what are my x values? All right, so that would be x minus 2 equals 0, or x equals 2. X plus 3 equals 0, so x equals -3. And that is my solution. Remember how I described when we look at the zeros on a graph, we can call them zeros or roots or solutions. Yes. B, I'm going to factor out my greatest common factor, and I'm done. So let's do with x equals 0, or x minus 6 equals 0, so x equals +6. I'm going to go through these ones really quickly because it is review and I want to focus on the next stuff we're going to look at, but I want the answers on here in case you need them. So x squared minus 9, there is no greatest common factor. I do see that they're both perfect squares and one's being subtracted. So I know it's difference of squares. That reminds me that I just square root each of them. That gives me x plus 3 times x minus 3 equals 0. So x plus 3 equals 0, excuse me, x equals -3. X minus 3 equals 0, so x equals +3. Let's go on to these next two. What looks different here is all of a sudden it's not equal to 0. We need to have it equal 0 first. So how do I do that? Well, I just move everything to one side of the equation, which would give me x squared minus 25 equals 0. I can solve this now. Again, it's difference of squares, perfect squares that are being subtracted. So x plus 5 times x minus 5 equals 0. Gives me x plus 5 equals 0, so x equals -5. Minus 5 equals 0, so x equals +5. Now this last one, let's work through it together for a moment. So we're going to have x minus 1 squared minus 9 equals 0. Now this looks confusing. You've got two options here. You could use FOIL and expand and collect and factor. Or you could say, hey, that's a perfect square because it's being squared, and so is this. It's still difference of squares. So that gives me, in a big bracket, x minus 1 plus 3 times x minus 1 minus 3. Put one too many parentheses. Equals 0, which leaves me with x minus 1 plus 3 times x minus 1 minus 3 equals 0. So there's my factors. And I have x plus 2 equals 0, so x equals -2. X minus 4 equals 0, so x equals +4. And again, sorry to just whip through that so quickly, but it is review. And if you want to go back on the video later, it'll be posted within an hour, or stick around after this and we'll talk about it. Right now, though, how do we find the zeros of a quadratic relation when we can't factor the equation? Take a look. I need to shut my door. Some loud lawn mowing going on. So looking here, what would our first step be trying to factor this? Our first step in every factoring problem to pull out the greatest common factor. So that would give me y equals -2 times x squared plus 6x plus 4. So now when we factor it, we need to look for the factors of +4 that will add up to 6. So I get 1, 4, -1, -4, 2, 2, -2, -2. I add them up, I get 5, -5, 4, -4. None of these add up to the value we need. So this equation can't be factored easily. So by easily, I mean with integers. It doesn't mean it doesn't have any solutions. It doesn't mean there are no zeros. What it means is that the zeros are decimals or fractions that we can't easily pull there. So how are we supposed to solve this then? Well, we have what's called the quadratic formula. All right, we just talked about this. Does it mean it has no solutions? No, it could mean the solutions are not integers. I think I pulled this out of the notes I posted online. If not, we are not doing this next section, talking about vertex form. Not getting into that today. We're going to scroll down to the quicker method. The quicker method to use is what we call the quadratic formula. This is the calculation I was talking about you're going to want a calculator for. So we are going to use the quadratic formula. It takes the a, b, and c values out of our standard form, and we sub it in here, and that's going to give us our 2x values. Now you might be thinking, how can a single calculation give us two possible separate x values? Because of this right down here. In one calculation, we're going to have x equals -b plus the square root of b squared minus 4ac divided by 2a. For the other zero, we would have x equals -b minus the square root of b squared minus 4ac over 2a. Okay, so there are two calculations embedded in this single one because of that plus minus symbol right there. I'm going to give you a second to copy that down. And then we're just going to put it into use, guys. I'm just giving you a tool, and we're going to try using it. All right. Let's try this out. Solve using the quadratic formula. You've got it out beside you right now. I'm just going to rewrite it at the top for easy reference. So x equals -b plus minus root b squared minus 4ac divided by 2a. So what do I recommend you do? At the start of every one, make sure that the equation is equal to 0. If it's not, you have to rearrange. The quadratic formula will not give us the proper answer if it's not equal to 0. What I then like to do is I like to write my A, my B, and my C values down the side for easy reference. So take a moment and write your A, B, and C values out, including the sign. What do we get? Put some answers into the chat, please. Great, thanks, Kendra. So our A value is 2, our B value is -2, and our C value is -24. And the signs are very, very important, guys, so don't leave them out. Now, let's start off. I'm going to start by writing out my full formula so that I have something that I know I can follow to put the information in. So write that out. And I'm just subbing in all of my A, B, and C values. Like that. Now I can't forget BEDMAS, so I need to do things in proper order. So brackets, nothing to do inside the brackets. I'm on to exponents first. I'm going to simplify a couple steps in one. So I can see that -1 times -2 gives me +2. Now, the square root acts as a bracket. I have to do what's under the square root first. -2 squared is 4. -4 times 2 is -8. -8 times 24 times -24 gives me +192. So I have 4 plus 192 under the square root, and it's over 4. Okay, so now I'm going to simplify this root. So I got 2 plus minus the root of 196 divided by 4. Here's where I'm going to split my plus and minus. So x will equal 2 plus the root of 196 is 14, or x will equal 2 minus 14, both divided by 2. That gives me x equals 8, or x equals 6. Apparently, we could have just factored this question, but now you've used the quadratic formula. Go ahead and try question B on your own, please. Follow this process. I'm going to give you guys 3 minutes to work through B. If you have a question, unmute and ask or throw it into the chat. Why is divided by 2 and not 4? Because I did it wrong. Thanks, Anna. Because I looked at 2. So 2 is 14 is 16 divided by 4 is 4. 2 minus 14 is negative 12. Divided by 4 is negative 3. Thank you. Start on B. I'm going to start slowly working through it in a moment. Quietly. Hey, here I go. I'm going to write out my, pardon me, A is 2, B is negative 1, D is negative 3. Start with my full quadratic formula. And I'm going to start subbing in. So negative times negative 1 plus minus the square root of negative 1 squared minus 4 times 2 times negative 3 divided by 2 times 2. So I end up with x equals 1 plus or minus 25 divided by 4. Let's split that up. So x equals 1 plus 25 divided by 4. And x equals 1 minus 25 divided by 4. That gives me x equals 6.5. Or x equals negative 6. There's my 2 zeros. And we can see here why we couldn't easily factor it. Are there any questions about that one we can talk about? Oh my God, thank you, Anna. So my brain is mush anyways. And I'm so distracted by the loud lawnmower going on outside. That's not my place. 1 minus 5. So 1.5 and negative 1. That's embarrassing. Okay. Are there any other questions? Let's take a look at C and D. What's different here? It's not equal to 0. So I remember I have to rearrange it to equal 0. That'll give me x squared minus 5x. 1's supposed to be a negative 2. Where am I looking, Anna? Up here? Are you talking about this one? That's B. Sakura, we're trying to find the zeros. So we found the zeros here, but we can see this. We use this. That's okay, Anna. Clearly, I'm mixing a lot up today, too. Sakura, we're trying to find the zeros for equations that can't be easily factored. So normally to find the zeros, we factor, we let them equal 0, we solve for x. But here, when we see a decimal, we're not factoring with decimals. So this method will work for every single quadratic relation, but you can see it's more work than simple factoring. Okay? All right, so let's take a look at C. And my calculator camera has crashed. Oh boy, guys. Okay, we're back. So when I rearrange C to equal 0, I'm going to have x squared minus 5x plus 3 equals 0. Now I can use my quadratic formula. You guys go ahead and work through that to find the zeros, please. So A is 1, B is negative 5, and C is positive 3. Start with my full formula. Now I'll sub in all my A, B, and C values. All right, so here, all of a sudden we're seeing we don't have a nice perfect square. We're gonna have a decimal. In most of the questions I give you, I'll specify how many decimal places to solve to. I'll usually say solve to 1 or 2 decimal places. Let's go to 2 decimal places now. So the square root of 13, when this splits, that'll be 5 plus 3.61 divided by 2, or x equals 5 minus 3.61 divided by 2. That gives me x equals 4.31, or x equals 0.70. I had to do some rounding here. I don't know about you guys, but I definitely do not want to factor an equation that has numbers like 4.31 and 0.70. You got this, go ahead and try D. When I start D, I made sure that I rearranged. So I had x squared minus 121 minus 100 equals 0. Well, I can simplify that to x squared minus 221 equals 0. My A value is 1. My B value is 0. There is no x term. My B value is 0, and C is negative 221. Go ahead and solve. All right, so I'm left here with 0, x equals 0 plus or minus the square root of 884 divided by 2. So that's going to leave me with square root of 884 is 29.73. So I'll have positive 29.73 divided by 2, or x equals negative 29.73 divided by 2. So I get positive 14.87 and negative 14.87. These are my zeros. Finish that up. We'll move on. We're going to do the back side of the page and one word problem together only today, just so you can see why it matters. We're going to do more word problems on Thursday. And then we're done. Guys, we're almost done our quadratic unit, period. Next week we have a test, and then we move on to trigonometry. We're just going to look at some triangles for June, and then be donezo. Okay. Sometimes A quadratic relation has no solutions. Draw two parabolas for me that have no solutions, no roots, no zeros. It might look something like a parabola that opens up with the vertex above the x-axis. Okay, it's never crossing the x-axis, so it has no real zeros. Maybe it's a parabola that opens down and the vertex is below the x-axis. We could not factor these, and even if we try the quadratic formula, we would get to an error, and we'll figure out why in a moment. So we use what's called the discriminant. All right, make sure you can recognize this term. The discriminant is the portion of the quadratic formula that's below the square root symbol, so b squared minus 4ac. We use this as a quick check to see how many real roots are there. We see if the value of the discriminant, once we sub the numbers in, is greater than 0, there are 2 zeros. If the discriminant is equal to 0, that means that it sits, there's 1 0. So that would mean it sits on the x-axis like that. And if b squared minus 4ac is less than 0, there's no zeros. Let's put this into action and we'll see why. So for each of these, I want you to just do the first step first. Step 1 only. For each one, we're going to identify our A, our B, and our C values. And we're going to solve for the discriminant, which is just b squared minus 4ac. That would give me 2 squared minus 4 times 1 times 9, which would give me 4 minus 36, which gives me a value of negative 32. It is less than 0. Therefore, no real roots. Let's look at why though. Let's say I was doing the full quadratic formula. So I'd have x equals 2 plus minus the square root. We know what my discriminant is. I'm just going to sub this in here. Of negative 32 divided by 2a is 2. What problem do we run into once we split it? Try and calculate this for me. So on my calculator, if I try to get the square root of negative 32, yeah. If I try and get the square root of negative 32, my calculator does not enjoy it. I get an error. Okay, this is because we can't square root a negative number. So as soon as we see a negative value under there, we know that we can't finish solving this. There are no real roots. Go ahead for B and C and determine how many roots there are, please. I don't want you to find the roots right now. I just want you to determine how many there are going to be. For B, when I sub everything in, I end up with 16 minus 16, which gives me 0. Well, our discriminant is equal to 0, which we know means there's one real root. Do the same for C, please. So I end up with a value of the discriminant as 4. B squared minus 4AC, my discriminant is greater than 0. So how many zero or roots will there be? 2 roots is correct, Grace. Now I know the question says state the roots where possible. We're going to move on. Practice it on your own. So the question is then, if 2 real roots exist, when should we be using the quadratic formula? That's a lot of effort. All right. So should you use it for every one? Well, it would give you the answer, but that's a lot of calculations when sometimes simple factoring will help. So when should you use the quadratic formula? When the equation can't be factored. So if you are trying to factor a simple trinomial, or it's a complex one with no common factor, I haven't taught you how to do complex factoring, can't be factored, solved by factoring. So if you're trying to factor and it's not working, go to quadratic formula. And on the problem set that I've given you this week, I said 1 needs to be solved by factoring, 1 needs to be solved by quadratic formula, the rest are your choice. You still have to show me full solutions, but it's your choice. And a note on that problem set, I made it due next week. So not by Sunday, I think by Wednesday I made it due. I gave you a couple extra days because it's going to help review for the test as well. Let's try one word problem together, and then we're done for today. We're back Thursday. This is a word problem from your textbook. A ball is thrown up into the air. Its height, h in meters, after t seconds is represented by h equals, I'm going to rewrite it, I don't like the way mine's formatted, h equals negative 4.9 t squared plus 38t plus 1.75. And I don't know if you remember, but back when we started looking at some of the word problems and I would say, oh, it's always -5, blah, blah, because we're rounding. Well, now that you know the quadratic formula, I'm going to give you the actual physics values. So question A says, what is the height of the ball after 3 seconds? That's when t equals 3. So all we're going to do is sub in 3 wherever we see t. And solve. What do you get? Good job, Kendra. 71.65. So therefore, the height of the ball after 3 seconds, or at 3 seconds, is 71.65 meters. B asks us, for what length of time is the ball above 50 meters? I'm going to sketch this out a little bit here. So here's our parabola. This is the ball being thrown. If this is 50 meters, it's asking. So we're going to find the points when it was at 50 meters, and we want to know how long exists between those 2 points. This is when h equals 50. So I would sub that in. I would have 50 equals negative 4.9 t squared plus 38t plus 1.75. I need it to solve. I need it to equal 0. So I'm going to bring this 50 over to the other side. Negative 4.9 t squared plus 38t plus 1.75 minus 50. And I can simplify that. To negative 48.25. And I see that my A value is negative 4.9, my B value is 38, and my C value is negative 48.25. I'm going to use the quadratic formula now. Solve for this. Our x variable is t this time, so I'm going to replace it with t equals negative b plus minus the root of b squared minus 4ac over 2a. Take a couple moments and solve this for me. I'm going to talk this through in one more minute. All right, so what does this mean? What this means is these are the two times on our graph where the ball is at 50 meters. So here I would have 1.6 seconds, and here would be 6.16 seconds. All right. The question, though, has asked for what length of time is it above 50 meters? So we need to know the length of time between these 2 points. So time is going to be 6.16 seconds minus 1.60 seconds, which gives me 4.56 seconds. So the ball was above 50 meters for 4.56 seconds. I want to skip C for a moment and go to D first. When does the ball strike the ground? And unfortunately, we lost some space here. We're going to run out of it. We're going to go, so when the ball strikes the ground, that's when height is 0. So if I go to my original equation of 0 equals negative 4.9 t squared plus 38t plus 1.75, and I have it equal to 0, solve for t here. So again, do the quadratic formula. So as I worked through, had some annoyingly complex numbers, but I get the two roots are positive 7.81 seconds and negative 0.05 seconds. We can't have negative time. Therefore, we're going to call this inadmissible, which means right here, 7.81 seconds is when the ball hits the ground. How is it possible to have a negative time? I'm going to move back up to our graph for a second. I'll be back. So up here, if we look at the equation, the initial value is 1.75. That makes sense because it's being thrown by someone's hand. So that means that when time is 0, the ball still has already a positive height. When we backtrack over here, that's just completing the parabola. It's the imaginary path of the ball. All right, so if the ball was allowed to go in reverse, it would hit the ground backwards at negative 0.05 seconds. But again, we can't have a negative time. So when we see that, we're like, great, that's not the answer. This one is. We're going to go up to C, which will just take us 2 minutes, and then we're done. Sorry, we went long. So C, what is the maximum height of the ball? Here's why I wanted to do it backwards. Up first, we're going to find the axis of symmetry. We're going to take my 2 zeros that I just found right here. I'm going to add them together. So negative 0.05 plus 7.81 and divide them by 2. And I get the x coordinate, or the t coordinate of the vertex, is 3.88. And now I'm just going to sub that in to find the height. And that's it, guys. That's our lesson for today. I know that there's 2 more word problems on the back. If you want to challenge yourself to these, go ahead and take a look at the completed notes I've posted on D2L. We are going to talk exclusively about word problems on Thursday. So I'm going to leave those for now. I'm going to stick around for another half hour if you have questions, if you want to go over something again. If you're feeling like I could try this, you're done with me, go take that on. Thanks for coming in.